Hello students, in rotational dynamics, today we are going to study the vertical circular motion. Always the student have the complaint about physics that they do not remember the things at the time of examination. So today at last we are going to discuss about some tricks how to remember the things or the derivation. So to start with the vertical circular motion. The vertical circular motion is of two types. One in which the motion is governed not by the gravitational force only. Means we have to supply the energy externally so that it performs vertical circular motion. What is vertical circular motion? As you know, when the motion, circular motion, is in vertical plane, then it is known as vertical circular motion. We enjoy the giant wheel in vertical manner in the Mela. So there the speed may be kept constant, but when the speed is kept constant, it is not governed only by the gravitational force, but some energy is constantly supplied to the system. The another type of vertical circular motion is the vertical circular motion which is governed only by the gravitational force. We are going to discuss the second type of the circular motion, vertical circular motion, that is which is governed only by gravitational force. For this type of motion, initially we have to supply the energy to the system. For example, if we take a stone or a bob and tie it to the string and we give a horizontal velocity to that bob, then the bob will move along a curved path. If the energy is sufficient, it may cross the top of the circle. Initially, if the energy supplied is small, then it may oscillate. But if we supply the sufficient energy to this bob, then it may perform the vertical circular motion. Here at the point B, that is the lowest position, the kinetic energy is maximum. Here we imagine that it is ground level. So at ground level, the potential energy is minimum or zero. As we move up, then the potential energy will increase and the kinetic energy will decrease. The part of the kinetic energy is now being converted into potential energy. Hence, at the top of the circle, the potential energy will be maximum and the kinetic energy will be minimum. As the kinetic energy is minimum, we know that the kinetic energy is half mv square. That is, the velocity is minimum at the top of the vertical circle. We are going to find the different quantities, that is minimum speed at point B, that is the lowest point, the minimum velocity or the speed at the point A, minimum speed at point C or at point D, so that the object can perform vertical circular motion. So to start with the discussion, we must know that the vertical circular motion is a non-uniform circular motion. Here you can notice that if we mark point P here, then at point P, the different forces acting on the body are its weight, which acts vertically downwards, and the tension in the string, which is given by Tp. It is acting along the length of the string and towards the center of the circle. O is the fixed point. So tension always acts towards the fixed point along the radius or along the length of the string, like this. Always the tension is pointing towards point O, which is the center of the circle. Here tension is Td. Here I will mark tension as Tc. They are equal in magnitude at point C and D. The tension is maximum at point B. As we move upwards, the tension decreases. Here I have drawn a long arrow because the tension is maximum at point B. So this tension Tb is large. Tp is less than Tb. Td is further less than Tp, and Ta is smallest. So in this manner we should remember that the tension, it decreases from the lowest point to highest point. When the body reaches at highest point, then it moves in downward direction. The potential energy is now converted into the kinetic energy. As the potential energy decreases with decrease in the height, the kinetic energy goes on increasing according to the principle of conservation of energy. So here the tension and mg. Also you may have noticed that I have drawn the length of the vector mg, that is weight, the same everywhere. Because the weight of the body will not change, we have to draw the equal length for mg, showing mg everywhere. Here also I have shown mg, having the same magnitude. But the tension is different at different points. The resultant of these two forces, that is the tension and the weight, will decide the necessary centripetal force here. Here at point P, the resultant of the tension and the weight has a part which is tangential to the circle. Hence, this tangential portion or part of the resultant, it changes the speed. At point D, you can see that the mg is in downward direction. So particle is moving up, but mg is directed in downward direction. So this tangential component will try to slow down the motion of the particle. Means it retards the motion of the particle. It tries to retard, slow down the motion of the particle. On the other hand, when the particle reaches at the point C, mg is in the same direction as that of the motion of the particle. So this mg, weight of the body, it accelerates the particle. So here the mg tries to retard the motion, whereas here at point C, the mg, that is weight of the object, it tries to accelerate the particle. So we shall discuss the velocities at top point, at bottom point and at midpoint. And also we are going to find the difference in the tension at the top point or highest point and lowest point. So at point A, at highest point A, tension and mg are along the same direction. Therefore, Pa plus mg is equal to, it provides the centripetal force, that is mVa square by r, where r is the radius of this circle. It is nothing but the length of the string. So this is the important equation number 1. So Ta can be written as mVa square by r minus mg. This is equation number 2. Now from this equation, if we have to calculate the minimum velocity, then on the other side there is mg and Ta. So mg, the weight of the object, can never be 0. Therefore, only the thing, it is constant, mg is constant. Only the tension can be reduced. So here from the figure we are marking that the Ta has least value at point A. So at point A, Ta can become 0. So we are going to calculate the value of the speed at point A by keeping Ta is equal to 0. So if Ta is equal to 0, then from equation 1, we get, what we get? mg is equal to mVa square by r. M will cancel, so gr is equal to, let us now find the speed at the lowest point B. For that, we will use the principle of conservation of energy. So, total energy at point A is equal to total energy at point P. So total energy means kinetic energy plus potential energy at point A is equal to kinetic energy at point B plus potential energy at point B. What is kinetic energy at point A? It is half mVa square. What is potential energy at point A? It is always mgh. But h here is equal to this r plus r is equal to 2r, where r is the radius or length of the string. Hence, it is 2 mgr is equal to kinetic energy at point B is half m Vb square plus potential energy at point B will be 0 because B is considered to be at ground level, and at ground level H is 0. So mgh, that is potential energy, is 0. Now I will transfer this term to the other side to obtain half m Vb square minus half m Va square is equal to 2 mgr. Half m is taken common. So in the bracket there will be Vb square minus Va square, and it is equal to 2 mgr. M is on both the sides of the equation, so it will cancel these two. So equation is now multiplied by 2 to obtain 2gr is equal to 2 into half is 1. So Vb square minus Va square. This is one of the important equation which will help us when we calculate the difference in the tension at bottom point and at the top point. So then here we have to substitute the value of Va to obtain Vb. Hence 4gr is equal to Vb square minus gr. As Va is equal to under or Va square is equal to gr here, so we shall substitute that value. When it goes to other side, it becomes plus. So 5gr is equal to Vb square. Hence Vb will naturally be equal to under root 5gr or Rg. This is the important equation, that at bottom point the minimum speed must be at least equal to under root 5gr, so that the object can complete the vertical circle. Then we are going to find out the difference in the tension at lowest and at highest point. For that, I will have to write the equation at point B. At point B, the resultant of the tension, that is Tb, and the weight mg will provide the necessary centripetal force. As Tb is in vertically upward direction, mg in vertically downward direction, the resultant of these two, that is Tb minus mg, will provide the necessary centripetal force for the circular motion. So it is equal to m Vb square by r. Hence Tb is equal to m Vb square by r plus mg. So this is equation number 6. From equation 6 and equation 2, it is clear that for Tb, mg is added to this term, whereas for Ta, mg is subtracted from this term. Therefore, Ta will be less than Tb. It is, we are sure about that Tb is always greater than Ta. Therefore, I will subtract equation 2 from equation 6. So equation 6 minus equation 2 will result into TB minus TA is equal to TB as it is m VB square by R plus mg, and minus TB means minus TA means m VA square by R minus m VA square by R, and minus of minus means plus mg. So it makes 2 mg. So we will get m by R VB square minus VA square plus 2 mg. We have already calculated the value of VB square minus VA square. It is equal to 4 gr. So let us substitute for VB square minus VA square as 4 gr plus 2 mg. Now this r cancels with this r, giving us 4 mg. 4 mg plus 2 mg gives us 6 mg. So this is the important equation number 7, which gives us the difference in the tension at the bottom and the top point. So we have found out the speed at the top point by finding resultant of the tension and the weight. So you have to remember that while finding the speed at topmost point, we have to use the equation PA plus mg is equal to mVA square by R. So this figure is very important. Drawing of the figure is very important, and then from the figure it is simple to write down PA plus mg is equal to mV square by R, and we have to substitute TA is equal to 0 in order to obtain the equation for V. So in this manner we should remember this derivation. After that you have to use the principle of conservation of energy at point A and at point B. It should be applied to point A and point B to obtain the speed at minimum speed at point B, that is at the lowest point. Means the two things are very important: resultant of the tension and the weight acting at the point, and second thing is the conservation of energy. When we have to find out difference in the tension, then we have formed the equation for TB from the figure itself, and then the equation of for TA and TB are used to find out the difference in the tension. So in this manner we should remember the logical steps, that is the resultant of TA and mg is important, the resultant of TB and mg is important for finding the values of the velocity, and here the difference in the tension. And also we should use the principle of conservation of energy to find the speed at minimum speed at the bottom point or the lowest point B, so that for the particle it is possible to complete the vertical circle or vertical circular motion. Now let us find the speed at midpoint D or point C. For calculating the speed at midpoint, such as point D or point C, again we have to use the law of conservation of energy. Let us write according to this law the total energy at point A is equal to total energy at point B. So total energy means again kinetic energy plus potential energy at point A is equal to kinetic energy at point A plus potential energy, we are going to write here point D, at point D. So at point A the kinetic energy is half m Va square plus potential energy at point A is 2 mgr is equal to kinetic energy at point D is half m Vd square plus potential energy is mgh, that is mgr. Now here Vd is greater than Va because as we move upwards the kinetic energy goes on decreasing. Therefore I will transfer this Va square to the other side. So half m Vd square minus half m Va square is equal to 2 mgr minus mgr. So it will make mgr is equal to half m is common, Vd square minus Va square. Now this we have to multiply by 2 to get 2 mgr is equal to m in bracket Vd square minus Va square. M is on the both sides, so it will cancel. So 2gr is equal to Vd square minus Va square. We know the value of Va square, it is nothing but gr. So Vd square minus gr is equal to 2gr. This minus gr is transferred to the other side to obtain 3gr is equal to Vd square. So Vd is equal to under root 3gr. So same is the case for point C. So this equation is important for calculating the minimum speed at midpoint so that the object will be producing the vertical circular motion. Now what about the tension? Here the tension Td provides the necessary centripetal force for the circular motion, and therefore we will write Td is equal to m Vd square by r. We have just now calculated the value of Vd or Vd square. Vd square is equal to 3gr and m is here divided by r. So r will cancel with this r, giving us 3 mg. So the tension at point T, rather the difference in the tension, because we have assumed that the tension at point A is 0. So difference in the tension at midpoint and at the top point will be 3 mg. In this manner, we have found out the equation for the speed at the midpoint and the difference in the tension at the midpoint and at the highest point. So, here for points such as point P, we can again find out the values of the velocity and the tension also by using the thing that the tension acts along the radius towards the center and the weight acts vertically downwards. Here again the weight mg is resolved into two perpendicular components, and as seen from the figure, Tp and mg cos alpha, they are in opposite direction. Therefore, we will obtain the equation Tp minus mg cos alpha is equal to m Vp square upon r, and from that we can find out the different values. So, rest things about this vertical circular motion will be discussed in the next lecture. Thank you.